All right, continuing on, you should be familiar at this point with how to switch from mixed to entire or entire to mixed, because that's going to come into play, especially if something's being asked to be written in lowest terms, like we have with this question. We need to be able to take that into the lowest mixed form is what that's really asking for. So entire radicals down to mixed. All right, multiplying radicals is really quite simple. Whatever is under the radical sign, those things get multiplied together. Any number that's outside of the radical symbol, they get multiplied together. So I'm going to jot that down in here, but you'll see some of these are entirely under radicals and we just multiply those pieces together. Some of them, like in part C, we start to mix them. So we have a -4, which is outside, which is going to get multiplied with the +2 here, and then that gives -8. This 6 and this 3 get multiplied, but that stays under the radical symbol. It's going to be the square root of 18, which then we have to do some more things with. So let me type that up here, and then we'll get started on our examples. Okay, so numbers in front of the radical symbol get multiplied together, and the numbers under the radical symbol get multiplied together. So in example A here, both the 5 and the 11 are under the radical signs, so we just multiply 5 and 11 together. Again, I could write a step in here, and I will, but I normally will start leaving this out. We're just going to take the 5 and the 11 and keep it under the radical symbol. That's going to give us the square root of 55. Now, if you can go from here to here, that's perfectly fine. Okay, just multiply the things underneath. Part B, if we do the same thing, 6 times 14 gives us 84. So we're going to have the square root of 84. And I didn't talk about the square root of 55, but I want to talk about this one here. It says we have to do this in lowest terms. With 55 in part A, there's no perfect square that will divide 55 evenly. Okay, so if I try 25, it doesn't go evenly. If I try 16, it won't go evenly, and so on. With 84, however, I do have a number that will divide 84 evenly, one of those perfect squares, and it's 4. If we check, 4 times 21 will give us 84. So what I'm doing now is taking that square root of 84 and writing it in its mixed form in lowest terms. That's going to give us the square root of 4 times the square root of 21. And 21, there's no perfect square to go into that. We've picked the largest one already. Square root of 4 is 2, so that equals 2 times the square root of 21. Okay, so like I said with part C, the numbers outside the radical symbols, they get multiplied together. So -4 times 2 is a -8. And then the numbers inside the radical symbols, they get multiplied together. So that's going to be the square root of 6 times 3. 6 times 3 is 18. Now I'm going to check, can I break 18 down into a perfect square times another number? So if you know your number facts, this is very helpful. 9 times 2 is 18, and 9 is a perfect square. So knowing your perfect squares and then knowing your number facts is very helpful for this. All right, so that's going to give you the square root of 9 times the square root of 2. And the square root of 9 is really a 3. I'm taking an extra step. Again, you're going to get to the point, hopefully, that you don't need quite so many steps. But if you do, that's perfectly fine with me. -8 times 3 is a -24 times the square root of 2. Okay? Now, with the next example, I have a monomial. I have my square root of 5, and it's multiplying a binomial. So just like if you had like 3, let me pick different numbers here. If you had a 5 times a 2x minus a y, or minus a 5, you know how you would hop through the bracket? The same thing is going to happen here. I'm going to multiply this first term, the 2x root 3, by a root 5, and then I'm going to multiply the root 5 by the root 5. So when we do that, this is a 1 in front. 1 times 2 is still 2. Root 5 times root 3 is root 15. And then we have our minus. 1 times 1 is 1, and then root 5 times root 5 would be root 25. Square root of 25 I can actually evaluate to be a 5. And if I check 15, 16 is too big, 9 won't go in evenly, nor will 4. So I think that's going to stay a 2 root 15 here. Okay? And that's as far as we can go. This can't combine any further because one has a radical, one doesn't. Part E, you've got a binomial, times another binomial. It's just like your algebra skills. We're going to take this first term of 2 root 3, 2 roots of 3, and it's going to multiply both terms here, and then the minus 7 root 6 is going to multiply both of the other terms, the root 3 root 10 plus the root 15. Why don't you put me on pause and you try that, see if you can manage through that for practice, and then you can check. Okay, so 2 times 3 should be a 6. Root 3 times root 10 would be a 30. Plus 1 times a plus 2 would be plus 2. Root 3 times root 15. 3 groups of 15. What is 3 times 15? That's 45. Okay, had a brain moment here. And then minus 7 times 3 is minus 21. 6 times 10 should be 60. Minus 7. And then 6 times 15. Ooh, that's 90. Okay, now I'm going to see if I can break anything down here. I think 30, there's nothing that will work with that one. There's no perfect square that will divide 30 evenly when I look through my list. But 45 I know is 9 times 5, so that one will break down, go smaller. Then we have 60. 4 goes into 60 15 times. And then we have 90, I know is 9 times 10. And that's the biggest one on that. We're almost done. 6 roots of 30 plus. Now, this is where hopefully you're getting comfortable. You could go directly to 2 times 3 there. Root 4 times root 15. Okay, so that'll be 2 times 3 times the square root of 5 for that piece. Minus 21 times 2 times the square root of 15. Minus, I don't know how I do that sometimes. If I try to undo it, I don't know how. Maybe you didn't notice, but the screen kind of jumped. It's probably my finger touching the screen while I'm trying to write. Alright, so that should give you a plus 6 root 5, 6 roots of 5, minus 42 roots of 15, and then minus 21 roots of 10. And that's as far as we can go with that. Under the radical symbols, we have nothing the same. I've got a root 30, a root 5, a root 15, and a root 10. These would all be not like radicals. If I had things the same, then I can start doing adding and subtracting of radicals. I can combine what we call like radicals, which is what I'm going to do quickly on the next screen here. Okay, so adding and subtracting radicals, it's like algebra. If you have all x's, you can combine your like terms. It's the same idea here. So I'm going to type that up and you can get it copied. Okay, we can only add or subtract like radicals, ones that have the same radical parts. So if you look at example A here, we have a root 3. Oops. Yeah, root 3. So that would be like having 1 root of 3. And then we have plus 7 roots of 3. So think of that as like a 1x plus 7x. It's just, instead of x, we have root 3. So 1x plus 7x would be 8 x's. So instead, what we have is 8 roots of 3. Okay, and then we have a minus 2 root 5 plus 8 root 5. Think of that as minus 2y plus 8y. Altogether, that should be plus 6y, or plus 6 root 5. So it's very similar to our algebra here. Okay, easy peasy, I hope. Part B, though, gets a little complicated because if I look at these radicals, none of them are like radicals. But I know that I can write things in lower terms, and then I might have like radicals. So if I look at the root of 18, I know 18 is 9 times 2. I could break that down. I know that 27 is 9 times 3. I know 32 would be 16 times 2, and 75 could be a 25 times 3. Change those into their mixed form lowest terms, and then you can collect your like radicals. Try that out. Okay, so I've done some work here. I broke them into the perfect square times another number, and then I took the square root of my perfect square and threw it in front. So I've kind of skipped that step now where I broke it into the two pieces. And then I did my multiplication where I needed to, like the 2 times the 3 and the 4 times the 5. Now I can put my like radicals together. I've got 3 roots of 2, and I'm going to subtract 4 roots of 2. So I had 3, but I took 4 away. That's going to be negative 1 root of 2, or negative root 2. Putting the root 3's together, I have 6 roots of 3, and I take 20 roots of 3 away from that. I think that's minus 14 roots of 3. Okay, and there's our simplified form. Pretty simple. All right, dividing radicals works exactly the same as multiplying, only this time you're dividing. Things under the radical signs, they get divided. Things outside of the radical symbols, they get divided. All right, so why don't you try part A, B, and C. See if you can get those figured out, and then you put this on pause, and then you can press play again. Okay, I have my answers up for you. The first one was square root of 6. The next one's negative 3 root 7. And the next one, 24 divided by 3 is 8. 18 divided by 2 is 9, but I can take the square root of 9 and get a 3. 8 times 3 is 24. Similarly, if I got an answer that could still go into lower terms when I did the division, I should do that. You can try the next if you wish. I'll do a new video for it.